Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. Today's topic is Debroglie wave theory or Debroglie dual behavior of matter from the chapter Atomic Structure. So, according to Debroglie, speaking about Debroglie wave theory, the wave nature of electron was first proposed by who? Debroglie. Already we know that light already we know that light light has two natures, or electromagnetic radiation has two natures. What are those two natures? One is particle nature, another is wave nature. How do we say that it is having particle nature? If that is possessing momentum, then we say that it is having a particle nature. And if it is having characteristics of wave, one of the characteristics of wave is wavelength. One of the characteristics of wave is wavelength. If it is having some wavelength, then we say that it is having wave nature. Okay. So de Broglie, already before de Broglie, it was found that photon means photon. We have studied that these are the particles of light or electromagnetic radiation. Okay, so light energy is having momentum. Momentum means it is having particle nature, and it is also having wavelength. That means it is having wave nature. So light energy is having both particle nature as well as wave nature. So in the same way, de Broglie is saying that as light is having particle nature and wave nature, electron should also have momentum as well as wavelength. So electron, already we have studied that it is having particle nature. In this de Broglie wave theory, he said that electron along with particle nature, it also should possess wave nature. That means it possesses wavelength. That is what he says. And from his experiments, he confirms that. So electron is not only having particle nature, it is also having a wave nature. Not only that, matter, any moving particle. See, according to de Broglie, all moving particles have wave properties. All moving particles will have wave properties. That means they not only behave as particle, they also behave as a wave. And these wave properties are important or significant only for particles of small mass and high velocity. Okay. So matter, he says that matter has dual nature. Moving matter has dual nature. That is particle nature as well as wave nature. So this wave characteristics or wave-like behavior is significant only when the particle has very small mass. So mass of the particle is very small, and if it is moving with high velocity, then only wave nature will be significant. See, for example, bus is moving, bus is having a very large mass, and bus is moving with less speed or velocity, then we cannot observe the wave property. We cannot observe the bus as a wave. So when the mass is more and when it is moving with less velocity, then its wave nature will be less. So here wave nature will be more when mass of that particle is small and velocity is high. When mass is high and velocity is small, then wave nature will be very less. Okay. So what Debroglie says, moving matter or moving particles of matter has two natures, particle nature and wave nature. In the same way, electron as it is microscopic particle, very small particle, electron is having two natures. It is not applicable, or we cannot observe the wave nature of particle which is having more mass. So to represent mathematically the wave nature of this microscopic particle, Max Planck derived a relation, a formula to find the wave nature in the terms of wavelength. So he derived a formula, is that lambda is equal to h by mv. So lambda is wavelength. Having wavelength means that it is having wave nature. So what is lambda? Lambda is wavelength. H, you know, Planck's constant. M is mass of particle. V, velocity of the particle. Okay. So how did he derive it? He derived it from two expressions. What are those? One is Max Planck's quantum theory. According to Max Planck quantum theory E is equal to hc by lambda. According to Einstein mass energy equivalence theory, very famous expression we have, E is equal to mc square. Equating these two equations, here also we have energy, then we can write it as hc by lambda is equal to mc square. Cc gets cancelled. Lambda is equal to, then what do we get? Lambda is equal to h by m into c. So what is c here? C is velocity of light, which is equal to 3 into 10 power 8 meter per second. Okay, velocity of light. So we are taking a light radiation. That light radiation is having a wave nature, and that wave nature can be expressed in the terms of wavelength, and that wavelength of light radiation is given by lambda is equal to h by mc. If it is applied to particles, microscopic particles, applied to microscopic particle like electron, having velocity v. V is velocity of electron. Then we can apply the same formula, because electron is microscopic particle and it is moving with very high velocity and it is having very less mass. Then lambda is equal to h by m into v. So this is the formula to calculate the wave nature or wavelength of electron. Already we know that m into v is equal to p, which is also called as momentum of the particle. So instead of writing lambda is equal to h by mv, I can also write it as lambda is equal to h by p, because p is equal to mv. P is momentum of the particle. Okay. Next, let us see here. Debroglie said that, now only we have studied that, Debroglie said that it is having wave nature, electron is having wave nature, and according to Niels Bohr atomic theory, he said that it is having particle nature. So Bohr's theory said that electron has particle nature. Debroglie says that according to Debroglie theory, he says that electron is having wave nature also. Wave nature. So finally it is confirmed that electron has both particle nature as well as wave nature. But to relate this both particle nature and wave nature, an equation has been derived, and that is 2 pi r is equal to n lambda. What is that? 2 pi r is equal to n lambda. Let us take electron is moving like a particle, and it is making it's moving around the nucleus in the circular path. For example, it is completing one circle. Okay. So when it is moving like a particle, we can say that it is completing one circle. So electron has started here at this point and reached the same point. So what is the distance traveled by this electron? The distance traveled is the circumference of the circle. What is the circumference of the circle? Circumference of circle is equal to 2 pi r. This is the distance traveled by the electron being like a particle. Okay. Now Debroglie says that electron is not only having a particle nature, it is also having wave nature. It is having wave nature. It is moving like a wave. It is moving like a wave. See, it is moving like a wave. It is moving like a. It's moving like a wave. When it is moving like a wave, it will have wavelength. So to correlate these two natures, an equation is provided, and that is called as 2 pi r is equal to, what is that? N lambda. 2 pi r is equal to n lambda. So this n lambda represents the wave nature, 2 pi r represents the particle nature. Right? Next, let us see. From this I can write it as what I can write, lambda is equal to 2 pi r by n. Okay. From this I can write that 2 pi r is equal to 2 pi r by n, lambda is equal to. So this formula is very important. Based on this formula, several times in competitive examination questions are asked, 2 pi r is equal to n lambda. So for example, if n is equal to 1, that means what orbit? First orbit. If n is equal to 1, then 2 pi r is equal to 1 into lambda. Integral multiple of lambda. See, when an electron in the first orbit travels one circumference, then how many wavelengths it covers? It covers one wavelength. When the electron is moving in the second orbit, when it completes one circle, then it is covering 2 pi r. What is r? R is the radius, right? When it is moving in the second orbit, if it is completing one circle, then the 2 pi r is equal to 2 into lambda. That means being like a wave, it covers two wavelengths. Being like a wave, it covers two wavelengths. If n is equal to 3, then 2 pi r will be equal to 3 lambda. In the third orbit, when it is completing one circle or one circumference, then how many wavelengths it covers? It covers 3 wavelengths. In this way, 2 pi r is equal to n lambda. And we also know that from de Broglie, lambda is equal to h by m into v. So let it be this equation 1, this equation 2, from equation 1 and 2, from equation 1 and 2, what can we write? What is equation 1? Lambda is equal to 2 pi r by n. Lambda is equal to 2 pi r by n. Lambda is equal to h by mv. Equate these two. 2 pi r by n is equal to h by m into v. From this I can write that mvr is equal to n into h by 2. So this is the equation, this is the formula which we have studied in Niels Bohr atomic model. What does this say? It says that the angular momentum of an electron is integral multiple of h by 2 pi. Angular momentum of an electron is integral multiple of h by 2 pi. So we have started with wave nature and finally we got the particle nature. Then, so hence de Broglie theory and Bohr's theory are in agreement with each other. It represents that electron is having not only particle nature, it is also having wave nature. Okay. So next one is here, what is this type of wave? This type of wave is a standing wave, also called as a stationary wave, standing wave or stationary wave, or we say that it is non-energy radiating wave. Other wave is non-stationary wave or energy radiating wave. Energy radiating wave. So when it is moving like this 2 pi r is not equal to n lambda. Okay. Next, coming to de Broglie applications. Already we have studied that the number of waves in an orbit is given by n. If n is equal to 1, number of the orbit is equal to 1, then the number of waves or wavelength. Waves means here wavelengths. How many wavelengths it covers? 1. If n is equal to 2, how many wavelengths it covers, it makes 2. In the same way, if n is equal to 3, how many wavelengths it makes? 3. Now only we have discussed. And number of revolutions of an electron per second, number of revolutions, that can be calculated as frequency. That is that called as a frequency. Frequency is equal to number of revolutions the electron is making per second. Okay. So when you are representing in mathematically, we write it as time. When you are defining it, we call it as per second. Okay. We know that velocity is equal to distance by time. Now, this is moving like a wave and it is also moving like a particle. So, if you consider particle nature, how much distance it covers? When it is making one circle, how much distance it covers? 2 pi r, circumference of a circle. Then t will be equal to, distance means 2 pi r by velocity. Okay. 2 pi r is nothing but the circumference of a circle. If you substitute this formula in the frequency, substitute the formula in the frequency, then what do we get? This is time, t. So frequency is equal to 1 by time, 1 by 2 pi r by v, that is equal to velocity by 2 pi r. Okay, velocity by 2 pi r. So that is what here, number of revolutions of an electron per second means we are speaking about frequency. Then relation between kinetic energy and wavelength of a moving particle. Let us see. We know that kinetic energy is equal to half mv square. Then v is equal to what you write, 2 ke by m under root, right? Simply rewriting this formula, what do we get? V is equal to root 2 ke by m. Then apply here, we know that lambda is equal to h by mv. Then it is equal to h by m into v, means already we have derived it as root 2 ke by m. Root 2 ke by m, that is equal to h by root 2 ke into m. So this is the formula, lambda is equal to, okay, h by root 2 ke into m. What is ke? Kinetic energy of the particle, moving particle. And what is m? Mass of the moving particle. Lambda, wavelength of the particle. H is Planck's constant. Okay. Next point is, let a charged particle like electron be accelerated with a potential of v. Then see, let us consider there are 2 points here, A and B. And the potential difference between these 2 points, there is potential difference or potential is V. Potential difference is V. Then when an electron is moving, accelerated, this electron is accelerated in this potential difference. That means electron is moving. Why electron is moving here? Because there is potential difference calculated, maintained between these 2 points. If there is potential difference between 2 points, automatically, if the circuit is complete, automatically the electron moves. When the electron is moving, it will have some kinetic energy. It gains kinetic energy. Right? So, when some potential difference is maintained between these 2 points, A and B, and a charged particle like electron is accelerated in this potential, then the kinetic energy attained by that electron, or kinetic energy of that electron, is given by E into V. What is E? Charge of that electron or accelerated particle, and V is the potential difference between those 2 points. Then if you apply here, lambda is equal to, we know that H by M into V. So lambda is equal to H by M into V. Already we have derived the formula. What formula we have derived? Lambda is equal to H by root 2 Ke into M. So instead of Ke, what I can write? H by root 2, instead of Ke is equal to EV. Already we have derived it. E into V into N. What is E? Charge of the electron. V is potential difference, and M is mass of the electron. Okay, so this formula is also important. Based on this formula, we are asked questions in the competitive examinations. So that is all about de Broglie dual nature of matter. Thank you very much. We shall meet in the next lecture. Right?